Welcome to Careers in Discovery, where you'll meet scientists who've forged outstanding careers in biotech and hear about what they've learned along the way. This podcast is brought to you by Singular, building brilliant biotechs. This week on Careers in Discovery, I am delighted to be joined by Nara Daubeney of Phaim. Nara, welcome to the podcast.
Thank you so much for having me, Tom. It's great to be here.
Great to see you. And I'm really interested to learn more about the work you're doing at Phaim and particularly this idea of antigenic immune modulation and how you're applying it to natural immunity as much as anything else. So it'd be great to start there and talk a little about the work that you're doing.
Perfect. Would be delighted. So thank you for having me. It's fantastic to tell you a bit about Phaim. And as you say, the aim in Phaim is antigenic immune modulation.
Yes,
so
okay.
We decided that that's a little bit of a mouthful. And of course, it's shortened to Phaim because it's pharmacological or pharmacotherapeutic.
Mm-hmm.
And our approach really is novel. I can't pretend we're the first people that have tried this approach because it's something that is potentially very exciting.
Yes.
But it's quite difficult to get right. But essentially, it's underpinned by looking for the origin of autoimmune disease.
Okay.
So what we try and do is recognize that there is a unifying cause, if I use the jargon term pathophysiology, why all autoimmune diseases happen, which is one of the reasons why if you've got one, you're about 5 to 10 times more likely to get another one.
Right, I see, yes.
So the understanding, or rather conventional wisdom, tells us that it is a little error, and it is a small error, but a very specific error in your immune system.
Mm-hmm.
So when you're developing in your mother's womb, all your immune cells go through an organ called your thymus, which for us, by the time we're born, and certainly in adulthood, is hardly there because it sort of shrinks away. But it essentially is almost like immune cell school.
Right, okay.
And it teaches your immune cells to say, this is part of you, so-called self, and this is not part of you, not self.
Mm-hmm.
And so if it's part of you, then you need to leave it alone. And it is that error that causes autoimmune disease.
I see.
You lose so-called self-tolerance. So you fail to, quote unquote, tolerate your own tissues. And as a result, you end up attacking it.
Mm-hmm.
And of course, the immune system is built in a way that when it attacks something, it should kill it and clear it away.
Yes.
And if the error is directed against a particular thing that's within you, then of course it destroys it. So what it means is that there is this unifying pathophysiology that underpins the disease, but for each disease state, that target is different.
Okay.
It's different in its tissue and is therefore different in the disease.
Yes.
So that's the background.
I see. Okay. So you are taking the immune system back to school.
Exactly. I think you actually stole my words right out of my mouth. That's actually what we say. We give these cells, we take them back to school and relearn natural self-tolerance, natural immunity.
Yes.
Essentially. And if you're able to do that, we say you're then able to do something quite important, which is to potentially prevent the disease.
Mm-hmm.
We're always very careful using the word cure because it's incredibly, emotive and is also quite a sweeping statement.
Yes.
But if you're able to intervene effectively and early enough, then you can modulate the disease. And it sounds slightly like semantics because we're not doing immunotherapy, which looks at trying to dampen down the downstream effect of the disease, if you will. We're looking and intervening much earlier.
Yes.
And if you do that, we hypothesize, or we say that if you do that, and you do that in a way that works with your immune system, then you're not suppressing the rest of your immunity. So, for example, we know that, say, chemotherapy works really well for, say, type 1 diabetes.
Mm-hmm.
Problem is, of course, your chemotherapy.
Yes.
So it's it's about a balance of risks and benefits. So if you are going to intervene in a disease modulating and modifying, potentially preventing way, you have to have a really good safety profile for that to work. So that's really, in some degree, the holy grail of all preventative therapies at all, but certainly for autoimmunity. Because for these people, for these patients, treatments do exist.
Mm-hmm.
It's just they come with their risks and long-term effects, ill effects to some degree, morbidity.
Yes.
So if you're able to intervene early and set the immune system back to how it's meant to be, then the hope is that that long-term consequence, that long-term cost, which is monetary to some degree to the healthcare system, obviously to you, the person, but more importantly, what you have to suffer during your lifetime as to what that disease brings.
Yes.
So we have to be really aware that what we're doing is making things better, not swapping one set of problems for another set of problems.
Right. And with something as complex as immunology, it's easy to fix one thing and break something else, right?
Exactly.
Yeah.
So we set ourselves apart by saying, if we know, so basically the holy grail of all autoimmune disease is finding out what is that target. That target that your immune system can pick up is called an antigen. So what is that antigenic target?
Mm-hmm.
That antigen is within you. So that antigen obviously could be a virus, could be a bacteria, COVID, say. But in autoimmunity, it's something that belongs to you. So it's a self-antigen.
Right.
And you have loss of self-tolerance. So if you know what that self-antigen is, then we hypothesize that you can then present that to your immune system very much like the thymus did. So going back to your point about, taking them back to school and teaching them, and your immune system can go, oh, I see. So I'm meant to tolerate this. Yeah. And the beauty of this approach is that you have all the other bits of your immune system untouched. So you can, you'll respond to colds just the same. Everything else will be exactly the same. There's no immunosuppression or immunocompromise. We are just resetting that very specific, very tissue and disease targeted immune response to its healthy, natural self-tolerance.
Yes. Fascinating. And I appreciate some of this will be confidential, Nara, so understood. But can you tell us a little bit about the science behind that and the sort of mechanism that you're using to modulate these areas?
So, yeah, absolutely. So normally the type of response that you have will be to a particular almost like a signal, a marker on a particular molecule that your body will recognize. Very often, not exclusively, but very often that's a peptide base. So it's just a bunch of amino acids holding hands. And that will be different between, say, type 1 diabetes, say, from psoriasis, both autoimmune conditions, giving all sorts of consequences in the target organ or the target tissue. So in type 1 diabetes, our hypothesis is that is a very, very specific thing that's exclusively found and is most prominent in the cells that are responsible for insulin secretion, called your beta cells in your pancreas. So this will be a pancreatic islet cell specific self-antigen, if I put all of those technical terms together. And the way that your body learns how it should respond to a particular antigen is dependent on a number of things, but broadly speaking, it's two things. Thing number one is, what is that antigen? So normally it's able to tolerate itself, the bit that you've lost at this point. And the second is so-called second signal. So your immune cells will not respond to things if they just see it just as a standalone presentation. So if you just see that, your body just goes, well, I'm just going to leave it alone. Right. So it needs what's called a second signal. And that second signal is incredibly important in telling your body, should I be responding it by killing it, or should I respond to it by tolerating it? Yes. So what we say is that our medicine, which actually is given as an injection, not into the vein, but into the legs, into the muscles, is that having the right antigen, self-antigen, presenting it with the right secondary signal, because it's mixed within that mixture, and putting it with the application, which is there's a little bit of how do you actually prepare that in order to be administered, gives you the right self-antigen with the right secondary signal in the right patient group at the right time.
Yes.
And then that becomes relatively obvious relatively quickly that is why a lot of previous approaches may have failed, is because there's a lots of ifs and buts and wherefores within that statement.
Yeah, I see.
Yeah, it can make things a bit difficult, because when we have discussions with potential investors, etc., very often the answer comes, well, a lot of people have tried that, and we agree with that statement, but we say that those in some ways failed or only moderately efficacious approaches, in some respects, because of all the things I've said about getting all these other bits right, almost prove our point. These have failed because those things that have not been necessarily the right patient at the right time, in the right mixture, with the right self-antigen, with the right adjuvant being the one that gives you the second signal. So all of these things have to come together in a perfect combination to give you that desired immune response. So that is in some ways quite the holy grail. And it is I think one of the reasons we're talking today, and I've really enjoyed your previous podcast, is because this idea of innovation. Innovation's a funny thing. We all sort of subscribe to that. We always, pretty much every single company, if you go to any sort of fairs or shows or bio meetings, everyone talks about bold innovators and all of that. Actually, if you look at any sort of innovation research, it's really less than 5% of people that are out there at the forefront of, pushing real step changes in innovation. And there's always that uncomfortable bit before it becomes, early adopters or late adopters or mainstream. So one of the things that has been a really interesting part of our journey in Phaim is actually making that cohesive argument that this is a steps change.
Yes.
We're not repurposing an old medicine. We're not picking out something from, a big pharma that they thought actually may not have been able to progress for whatever reason. We're saying this is actually quite novel. This is actually quite different. And this is actually needs quite a different approach. So it has made us a little bit out of the box as Phaim, I think. Yeah.
Yeah, and I suppose, as you say, you need to sometimes take those leaps to progress something. I think you probably, and this doesn't just apply to research, but it does certainly apply, when you make that leap, I think you have to accept that some people aren't going to get it, right?
And that's fine. Yeah, exactly.
Yeah, exactly.
Right. Yeah. So it's based, one of the questions that we very often talk about in the team and with our board, etc., is actually, who do we fit with and who fits us?
Yeah.
And we realized during that, because I think one of the things we tend to be quite good at is self-reflection and thinking, always constantly. And as a small biotech, you have to do that. You have to constantly, it's like a little, like a sailboat. You have to go, hang on, how are we going to catch this wind? And not jibe. How do you go and say, actually, a little bit of a storm is coming, and biotech is definitely going through a storm. So how do you batten down your hatches to keep going with that sailing analogy? And how do you who do you go with, and who comes with you? And I think recognizing that we are that innovative, that slightly out of the box, leap in terms of, certainly in the treatment of autoimmunity and specifically in type 1 diabetes, we've realized that the people that have been so helpful for us in this journey and the people that we best fit with and fit with us are the ones that go, actually, I like that moonshot idea. These are the things that will change. You might fail, because of course a lot of things do, because that's just the nature, that's just the probability argument. But the thing that's really exciting is to say, actually, it's good science, which should underpin all your research when you're a biotech. And let's see where it takes us.
Yeah, makes sense. And presumably, in principle, this approach can be applied to the whole gamut of autoimmune diseases, as long as you can identify the antigenic target, right? But I'm presuming there's some places that you're focusing. Where are they?
Yes. So type 1 diabetes, T1D is our main focus at the minute. Yeah. And the reason for that is, so people have said, well, why do you pick that one? And the simple answer to that is because we're very, very passionate about it.
Mm-hmm.
And we actually think that we've got something that will really change the treatment pathway for type 1 diabetes patients. The story actually began on that probably 40, I've got to think now, hang on a second, 45 years ago, because our CSO had trained in Hungary.
Right.
And to Hungarian medical school and was quite outstanding and decided very early on he wanted to be pediatrics, and on the ward saw a new onset type 1 diabetic who was 3-4 years old, not being able to comprehend why their mom was stabbing them with a needle every couple of hours. And the sort of the cruelty of that, and we've got better at it. The monitoring's better, the administration's better, the needles are better. All of the things are much, much better than they were, 4 decades ago. But actually, other than insulin, it's only in the last 5 years that there's been honest, real leaning in to actually this is a disease to be solved. And up until that point, really, we were 101-year anniversary of insulin. Prior to that, if you got type 1 diabetes, sadly, it was fatal. Mm-hmm. The only way we could keep you alive is to reduce the amount of insulin you needed. And the only way we could do that is by starving you. Mm-hmm. I mean, how cool. Yes. And then, of course, at least that now changed to being something where it didn't kill you necessarily straight away, but all the other consequences, obvious consequences of needing that. So that's kind of where the story began. And so, yes, exactly. But to your point, we feel that for T1D, for type 1 diabetes, we have got the right self-antigen.
Right.
And as you say, the holy grail is, what is that? And the next disease that we've got in our sights is psoriasis. We've got a patent, actually, of how to look at identifying what those self-antigens are, because we don't know what it is in psoriasis either. So step number one in that particular patient group is to say, well, what is it? Mm-hmm. That will be the next thing. So what we'd really like to do, or what our aim is at the minute, is to take the type 1 diabetes therapy, which we've actually taken through preclinical, we've taken through all the toxicology, which you need to know. We're ready to get our regulatory approval and take that into clinic. And in fact, actually, the clinical trial coordination will be run out of University of Cardiff. So Cardiff is very close to our hearts. And then, yes, take all those learnings and take that into the next disease, which we look to be psoriasis.
Mm-hmm. Makes sense. And your role, Nara, is as COO. And that is a title that means lots of different things in lots of different companies and covers a huge amount of ground usually. Tell us a bit about your focus, where you spend your time, and how you fit into the business.
So you always get these grand titles of C-suite. As anybody who has been in a small biotech, that is exactly basically just doing everything. You roll your sleeves up and you do everything from taking the bins out, making the cups of tea, holding morale high, as well as all the other logistics. So I'm really the contact point within Phaim, and I look after our direction, our communications, anything from accountancy to patent filing, etc. Mm-hmm. So we look after lots of moving parts, and we're a small but agile team. And we essentially any of the sort of clinical work and the lab work we at the minute contract out. I'm a medic by training, and my research background is in immunology. So the thing that excites you the most in some respects is actually doing the science. So one of the things we're really looking forward to as part of this next step is to get a research and development, an R&D lab.
Yes.
And continue doing the science. So you wear many hats. The most exciting ones are the ones where you're actually developing the science and moving the research forward. And it really is just the best feeling when you get some data back and you think that is showing exactly what I wanted it to show.
Right.
So those are the highs. Those are the bits that you live for. But yes, the grand title of COO, certainly in a small biotech, just means anything that needs to be done, you land on your desk and you pick it up and you do it. Yeah.
Yeah. Makes sense. So lots of variety and
definitely. But lots of exciting things as well. And every day is a learning day.
Yes, I'm sure. And you touched on it there, Nara, your background. And so you have a PhD in immunology, originally trained as a medic. And we were talking just before we started recording about how the path from medic to biotech hasn't always been a traditional path to take. So I'm interested to explore your journey with that. So, but to start with, tell us a bit about why medicine, why science, why this career for you to start with.
Yeah. So that's an interesting one. I'll distill it a bit. I always loved science. In fact, one of my favorite subjects at school was physics, and I really thought I was going to read physics. And
okay,
I think erroneously, actually, in hindsight, I thought, and I loved medicine as well. And I thought, if I did physics, I'll just be in a lab and I won't really interact with people, and I'll just do the science. And I love people, I'm a people person, and I thought I'd really miss that. I think that was an error on my part. I don't think that's what would have happened.
Right.
But because of that, I went down the medicine route. It's a really simple thing to say, but people who end up doing medicine, for the most part, really do want to help people. It's a real, sort of cliched term, but actually you have to like being with people.
Yes.
To do it. That's like one of the prerequisites, really, which is kind of glaringly obvious. And I love medicine, and I love the variety. I love the fact that it makes you very humble. You never know enough. No matter how much you know, it's never enough. And if you like learning, and if you think that's what my life's about, it's an incredibly rewarding career. Academically and intellectually, it's very stimulating. The bit that comes along with it, of course, is being with people. And one of the greatest gifts, I think, there's no greater trust to some degree than what people place in their doctors.
Yes.
If you think about it, what as a doctor, you have a relationship with a patient in any other setting, I mean, you can't, like as a surgeon, you can't cut into people without going to jail, unless, this is the setting. So the premise of your relationship with your patients is that everything I do is in your service. That's the deal. So I will keep myself up to date. I will know the best treatments. I will know the best therapies, and I will be able to communicate that to you so you can make an informed choice. So I'm meant to be your advocate, and I'm meant to furnish you with all the information you need for you to make the best choice for your health. And that's a service, and that's what you need to do. And I think that's a great privilege. And the only thing greater than that is when you're allowed to do that to someone's child. Someone gives you their child and says, "Look after my child," and that's never, it's never something, I think, that goes away in its enormity. And no matter whether it's a tonsil operation, which is really straightforward, or if you've got a much more challenging scenario, but I think it's the greatest gift. And that is why I think it will never be not something that is not important to me, and it's not significant.
Yes.
So that's the doctor journey. When I was a medical student, we had an amazing, fantastic, very sort of traditional in some ways surgeon who was my first clinical attachment. And normally when you're a medical student, you're really quite down on the pecking order. You're always in the way. You don't know what you're doing. And he was so encouraging, and he made you feel so part of the firm. I thought, actually, surgery will be something I think I really like this. Okay. So I didn't set thinking I was going to be a surgeon. But the more I did it, the more I loved it. And I loved head and neck anatomy. So I thought I'm going to do something in the head and neck. And as I trained, it became about ear, nose, and throat. The variability was amazing. You can do teeny tiny microscopic surgeries on the middle ear, or you can do big surgeries with head and neck cancers. I settled for a lot of sort of endoscopic surgery. So I do a lot of sinuses and airways, adults and in children. And it's just a lovely, as I say, it's a lovely, lovely specialty. But I really liked basic science. I did a lot of it when I was a medical student. And then I did that as a postgrad. I did a PhD in immunology, and I went back to clinical work. It was an interesting one. I suppose one thing to mention, which is something that is a challenge sometimes, is how do you then have a family within all that?
Right.
I thought I had my first child just before my PhD. Okay. One in the middle, one at the end, and then I went back to clinical work, and we thought, we'll have one more. So that was the fourth one, and that was that. Yes. And I finished my training, and then started as a consultant, and very shortly thereafter this idea of Phaim was born, and we thought, actually this is a really, really good idea. So So pick that up. We really just grew it from the ground up. And it's, to your point about how do you make that journey, how do you make that transition? I would say it's not for the faint-hearted.
Yes.
I think incredibly clear of what you're trying to achieve, because the road is long, a lot longer than anyone thinks. Mind you, that's always the way with anything worthwhile. So it was a thing that we thought the science was sound, the science was good. We could see a clear path to, when I say exit, I mean realization of this therapy being on the market and being applicable and useful. And there was a clear line of sight as to how this was going to work. So I think that's my journey, and I think Phaim has grown from strength to strength. And what we went for is data is king. It doesn't persuade all, because there's a lot about team, etc. But there is real power in being able to show that your idea works.
Yes.
So our early aims, and still are, is to keep accumulating stakes in the ground, showing that therapy works, that it's safe, that we've de-risked it. So there's a lot of self-reflection of going, what are our risks? How can we mitigate them? What is the next step?
Yes.
But yeah, so slightly unconventional, but that's what I would say. If you're going to make that step from medicine, most people actually go into bigger commercial pharma positions, which I think is a natural step. And I think a lot of people are doing that a lot more than certainly when I was training initially. It used to not be the done thing. I think for all sorts of reasons, which I won't bore you with. I think more and more people are making that sidestep. I think it probably is not, I don't want to say it's a one-way street, but I think once you've stepped out, it'd be very, very difficult to come in. So I think it's come back in. So I think it's a very difficult argument. Right. But I think if you're going to go for small biotechs, I think just be incredibly clear of what that journey looks like and your why.
Yeah, and I suppose you made that decision at a point in your life where you had a lot of responsibility, right? Some biotech entrepreneurs do it when they finish their PhD as a direct postgrad, or they do it as a postdoc or whatever, when perhaps they have less responsibility. But you had a successful medical career. You had 4 children. So you're crazier than me, Nara. I've only got 3.
Takes one to know one.
Yeah. Yeah, tell us a bit about that decision to go and start a business, because that is always a risk, even if you've got a great idea.
Yeah. So I think what it came down to is lots of talking, lots of discussions, lots of scenario working, and risk outlining, if you will, just saying, if we do it, what does this look like? If we don't do it, what does that look like? And I suppose in a very sort of philosophical way, a little bit came down to, without getting too deep, is your why? Why are you here?
Yes.
What is it? What is it that's going to, mean that, Tom or Nara, when we shuffle off this mortal coil, you want to see your kids, obviously, but beside that, what is it? And people sometimes say, oh, but you're a doctor, saving lives and all that. And you think, yes, definitely. And I always, have always done the absolute very best that I can, but I'm not arrogant enough to think that I'm the only one who could have done it. So if it wasn't me, it would have been another surgeon, who is going to be, able to do all that. But we looked at this and we thought, if we do this and this works, then we have a therapy that could prevent people from progressing down the inevitable slide into full-on insulin dependence, with all the long-term morbidity, mortality, and impact on your life that it would involve. And now, wouldn't there be, and this is not a sort of self-importance of making yourself more important, it's more a case of that would have been a really, really worthwhile course to go for. And what's the worst that can happen? The worst that can happen is we fail. But you have to take shots on goal.
Yes.
You just need to get 1 in out of 100, and that's a goal. Yes. If you've never taken it, it's a fail.
No,
So a
absolutely.
bit of it was about, if this works, then we've done something collectively, not just us, not me, Nara, not us, Phaim, because the people that are behind it. So like our early investors were all angel investors. They're all people who, like us, just believed in this. They realized this was a long shot. They realized there was no, we hadn't run a biotech before, which is one of the things that people go, how many biotechs have you exited? And you're like, well, none, but it's in the science, and we accept that, and we know that's a weakness. But at the same time, you go, but just look at this, look at these results, look at the data, look at the science. And yes, all sorts of reasons, which we're very open about, why something cannot work, but there are all sorts of reasons why it can.
Yes.
I think it was that saying, we've got 20, 30 years of active, really hard graft where you're able to lean in, and we've got PhDs, further degrees. We've run multi-center, multinational clinical trials. We're kind of like the people that CROs employed to run trials for them. So one thing we're not thin on the ground is, how do you make a clinical trial work?
Right.
And we knew that really, really, really well. And how do you look at getting the right data at the right point, at the right price? And we know that really, really, really well. So yes, we know a lot of things that we haven't done, but we knew a lot of things that we could do. And we're probably in one of the best, if not the best placed to do. So it's about having that awareness of, what are your risks? What can you bring to the table? Where do you need to get to? Identify any gaps. And then one of the things I think we're also good at is knowing what we don't know. So to be a Donald Rumsfeld about it, the known unknowns, which hopefully, if you keep an eye on, then the unknown unknowns become a bit more obvious as well.
Right.
And so you just pull people around you who are a lot better than you are at bits that you're missing, and being very honest about your shortcomings, of which there'll be several. But you can go, well, let's bring in a really experienced NED chair, someone who's done R&D before. Let's bring in Lisa Jenkins, who's fantastic, a real sort of veteran and stalwart in the space. Let's bring in someone with operational experience. So that's one of our newer NEDs, John Green, who runs One Nucleus So it's just basically, and you have to keep on going with that and say, okay, we've now moved from being a preclinical, we're now a clinical. So we now need to look at these sort of gaps in where we are, and that will evolve. So I think making that jump was about finding a sound and potentially groundbreaking scientific idea that was really worth the effort, recognizing that us as a group, from a scientific clinical trials point of view, are probably best placed to bring it, to practice, to life. Then just saying, okay, what are the things that we're not good at, and let's fill in those gaps.
Right. Yeah, makes sense.
So that's how that happened. Yeah.
And there was something you mentioned earlier that I wanted to pick up on a little bit, in that, if I think you were sort of advising that if people were thinking about making this step, to be aware of the realities of startup biotech and what that is like. So what are the things that you've realized about this industry and the things that maybe you weren't aware of that you know now?
So I think probably the biggest one is, which is a controversial one, and I suspect people who'd be listening to us may or may not agree. If they don't, please get in touch. I'd love to hear what is that I think the science is not enough.
Right.
We have had lots of discussions which were not even around the science. When you're a scientist, it's quite frustrating because you think, but that's, and so a lot of it is around, which I get, and I understand, and in fact, I actually agree with it. It's about the team. It's about the journey. It's about where you've been. And if you're attempting something that is a high risk, which therapeutics and first into man always is by definition, and high reward, then you are definitely at the riskier end of the proposition, which of course, because that's the nature of the beast, and therefore just look to marry up with people, organizations, funders, investors, etc. that would be best placed for you. I think when you start out, there is a dose of naivety. Certainly, if you're very empirically minded, that the science is the science, the data is beautiful. So what's not to love? And it's not as simple as that. So I think if you're thinking of doing this, obviously, I think depending on when you do it, if you're doing it relatively early on in your career, you probably won't have had the research experience, the people management experience, the clinical trials experience to jump straight into an early phase biotech. And to those people, if you're thinking of doing this, and by the way, it's an incredibly rewarding, incredibly exciting role, then bigger pharma and a commercial organization is the next reasonable, sensible step, which I think is where most people go. But if you have gained that experience, I think those people, so I've got a couple of friends who went out at the very end of their training. So they did about 15 years of training. In the UK, we erroneously call people after 15 years of qualifying junior doctors. Yes. Not a very good friend, I don't think, because they're not at all. They're highly, highly experienced and highly sought after. And they've now done something like 10 years worth in pharma. So that person would be perfectly placed to go and jump into a smaller biotech because they've got all that sort of 2-3 big pharma company experience. I think you've got to come to small biotechs with a lot of experience because or you have to have someone on the team who has done it before. I think experience counts for a lot because there's so many bumps along the road that is very difficult to foresee if it's a new one.
Yeah, this is something we advise quite a lot. We work with a lot of companies that are run by a group of people that have never even worked at a company, let alone run one. And that's okay. If that's what the founding team is, then that's what the founding team is. But I agree, you should absolutely bring someone in. If it's someone on your board or maybe another member of the team who knows how companies work and knows how businesses work and particularly knows how biotech businesses work, and ideally they've run one, but at least they've been in.
And it's not that big a group. Everyone before long ends up knowing everybody else. There's only, if you're in a particular, say if you're biotech, if you're digihealth or digitech or health tech or whatever, you will be different. But actually the groups of people, whether it's execs, C-suites, funders, grants, it becomes a bit of a, if I say a set pool, so people know everybody. So if you're coming on as a newbie, it's a combination of excitement, but also, who are you again? So you have a little bit of a track record, and you've got to be out there, telling your story and saying this is what we do, and if you like what you hear, come and talk to us, and we'll come and talk to you, not just from a funding perspective, but just even making connections. And people are incredibly generous with their time.
Yes,
that's the thing to say. People do like to see things succeed. They do feel incredibly, driven to help others. And not everyone, obviously, because humans are not straightforward creatures. But those people, there's a lot of them. There's a lot of them. I mean, the amount of support we've had for people for nothing other than goodwill has been tremendous, and it's always an incredibly deep learning exercise. I've learned a huge amount from people who were kind enough to give their time, and I've come back to them and said, okay, we talked about this. Can I ask you about that? And so I think you use that network. So that's if you've got gaps in your knowledge, which we all do, and experience, again, which we all do, seek out those who will help. And they are long-term supporters, long-term connections, and they're along for the ride. And that's great. That's a great benefit.
No, absolutely. And this may be something you've touched on already, Nara, but in terms of, I suppose, career advice in general, or things that you've learned about throughout your career, is there anything that perhaps for someone who's earlier on in this journey, or maybe that you wish you'd known about building a career when you started out?
So it's a very good question. So I'll probably answer it in two parts. I mean, I think one of the things is an easy one of the what to do. I think you've got to go and do things that set a fire in your belly.
Mm-hmm.
You've got, if something, you think this is really worthwhile and I'm loving this, do it. Like, doing a PhD when you're a surgeon, most people don't do that. A lot do, but a lot don't. I don't think there's any point in doing it unless you really, really want to, and it excites you. So always do something that you have a burning passion for, because there's lots of downtimes. Things sometimes are really, really, really hard.
Yes.
And if you think, actually, I love what I'm doing, then you're going to put up with those hard times. And that's true whether we talk about, in my case, surgical training, or setting up a biotech. So if it brings, if you've got a fire in your belly about that, then that should be the driving force. I think things that I would learn, that I would tell someone, I think it sounds like a simple one, but think of your why, which sounds like a self-help book, but I genuinely mean it. I think, what are you trying to achieve, and map it out. Spend a lot of time thinking, this is where I am, this is where I need to go. Appreciate that path that you think is linear is not linear.
Yes.
Success is not a straight line. It's a down and up, and more downs than ups, but hopefully the ups will get you to the top of the mountain in the end. And be really, really honest with yourself and self-reflective, and keep going and saying, okay, what did I do well? That's always a good one. What could I have done differently or better? Yes. And if you and be incredibly self-critical without being self-deprecating, because that should be the right balance of not arrogant, but also not to be undermined by constant self-doubt, which is paralyzing.
No, absolutely. And I think that point that you make there about reflecting on the things that you've done well as the things that you haven't is a really important one, because I think a lot of people, particularly, those people who would see themselves as achievers or as sort of driven people, sometimes forget to think about the things that have gone well, and you can end up in quite an unhealthy place with that, I think.
Yeah, absolutely. So I think if you know, and there's more help out there than you think.
Yes.
So I would say, I hate that word networking, but but don't network for the sake of network. Look for like-minded people, if I put it that way. Nobody, for example, goes into medicine necessarily for the money. They go into it because they feel passionate about it and being with people and helping people. And for the most part, I think people who start out on this journey are full of good intentions. They're trying to do things for the better. And so there's loads of people out there like you who are coming at it from a different angle, a different time, a bit more experience, a bit less experience. And again, to use another jargon, always lift as you climb. So if you can help someone else, do that. Yes. Treat people as the way you want to be treated. So just the same way you're desperate for advice. If you see someone, which you will be as you go along this journey, less experienced than you, go, here is what I learned. This is what I would do. And always, I always say that small biotechs are like pregnant women. They're never short of advice. So take it for it is. It's meant well, and it may or may not be applicable to you. You know your business best. Take from it, soak it up. Don't take it as gospel, because you're the one that's carrying your baby, going with the pregnant analogy. You're the one that has to nurture it, love it, bring it to its success. So take as much information as you can, bring it in, but be incredibly clear. What am I doing? Where am I going? How am I getting there? And what are my risks? And then pull it all together. So I think that's what it is. And that sometimes takes a lot of time. So make sure you've got the headspace to do it, because some of it is the doing it and some of it is the planning it. Yeah,
no, absolutely. I love that analogy, by the way. Nara, thank you so much for joining us. It's been great to talk to you.
It's been an absolute pleasure. Absolute pleasure, Tom. Thank you.
Nara Daubeney is the COO of Phaim, a biotech company using antigenic immune modulation to treat diabetes and other conditions. Nara joined us to talk about her transition from a successful medical career into the world of startup biotech, taking the immune system back to school, and why the fire in your belly should be your guide. Thanks very much for listening. Careers in Discovery is sponsored by Singular, helping you to build a brilliant biotech company. Biotech leaders spend far too much time, money, and energy on hiring and people issues. Head to www.singular-biotech.com to learn how you can recruit and engage your team more effectively so you can focus on developing medicines, treating patients, and saving lives.